So far we've seen how heat travels in solids. And the idea is that when I move one atom in a solid, because atoms are all tied up, the movement gets transferred to the following atom and so on and so on and so on until all the atoms are moving eventually. Now in fluids, which means liquids and gases, atoms are free to move around. So heat travels in a very, very different way, and that way is called convection. So here we can compare how heat is transferred in a solid with the way that heat is transferred in fluids. And remember that fluids are liquids and gases. So in a solid, the idea was that if I move this atom here, this atom will move the ones next to it, and then the movement will get transferred to the following atom, and then the following one, until eventually, after quite a while, the movement will have reached this one. That is, heat will travel from this atom until this atom gradually. And remember, these guys can't change positions, they're stuck in place. So all that gets transferred is really the movement. No atoms are really going from one place to the other. But in fluids, things are very different, right? Because in a liquid, I'm allowed to move atoms around. So this guy, I could put him there, and this one, I could put him in there, right? So imagine that I have a bunch of atoms over here that are moving very, 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 very fast. Then in a solid, my only option to transfer heat was to wait for these guys to heat the following ones and so on until the heat reached these guys over here. But in a liquid, I can just take all the atoms that are moving very fast and move them somewhere else. And this allows for a very, very fast transfer of heat. And the same happens in gases, right? Because if I have a bunch of atoms that are moving super fast in here, nothing prevents them from going to the other side of the gas. This is called convection. The idea that heat is transferred not by touching, not by the transfer of movement, but simply by taking the atoms that are moving faster and placing them elsewhere. Another reason that makes convection so effective is the fact that heating something up will make it less dense, right? So imagine that I'm heating some water up, and then the water at the bottom is getting hotter. And because it's getting hotter, the distance between atoms is getting bigger, and then this makes the water less dense. And remember, things that are less dense float up. So while the water that's already hot flows up, the water that's still cold goes down and then gets heated up. And this allows me to heat the water pretty much all at once. So instead of having to wait for the heat to slowly move out from here to there, I can just rely on the ability of the water to replace itself once it's hot enough. So if you've ever been to a beach town, you may have noticed that there's always a certain breeze that flows from the sea into the land. So why does this happen? Well, this happens because of convection. Normally, during the day, the ground is really, really, really hot because it's been heated up by the sun. So all the air that's next to the ground gets heated up and then goes up, then gets cooled down, and the one that happens to fall next to the water, since the water is a lot colder than the ground, stays pretty cool. So what happens is that all the air from next to the water tends to flow towards the beach, because here there's a void, right? There's all this warm air has gone up, and therefore there's space for the cool air to move in. And this creates a cycle that causes a wind right where you are at the beach. And at night, the opposite thing happens, because at night the ground has cooled down, and now it's the water that is warmer than the ground. So again, the cold air tends to go from the ground to the water, then it gets heated up, goes up, it falls down on the ground, and again gets cooled down, goes to the water, gets heated up, and so on and so on and so on. So the cycle keeps being repeated, but this time the breeze flows from the beach into the water. So it's time for some thinking again. Now, after all you've learned about convection and what you learned before about conduction, I want you to think about what's more effective for transferring heat. What do you think? Post your reply in the comment section, and then we can discuss it during class.